Okay, this is on your daily lessons, page 133. So we've got two runners, A and B, run on a straight racetrack. Again, they're boring. For 0 to 10 seconds, and the graph below, which consists of 2 line segments, great, shows the velocity in meters per second of runner A. So on this one, it's pretty unclear, or at least it's pretty little. So I'm going to say runner A and velocity, just so I really know that this is what I'm talking about. The velocity in meters per second of runner B is given by this function. So there's 2 different functions. You've got runner A, runner B. Runner A has graph, runner B just has a function given. Find the velocity of runner A and the velocity of runner B at 2. Okay, so the velocity of runner A, I'll do V and then I'll do a little subscript A, at 2. All I'm doing is going up and I'm looking at this. You think, oh, can I guess that? And the correct answer is, no, you can't guess that. And they're going to have problems like this because, you know, you're in calculus, so they want you to do algebra. What you need to do if you get to a problem like this is you can't just say 7. You can't say 7.1. You can't say it's around that value. You know it is, but you actually have to find what this line is and then plug in 2. So I know that you're hoping to substitute 2 in order to find this value of runner A. So if you need to stop the video and groan now, you can, but I don't have to hear it. So we've got 2 different points. I've got this point 0, 0, and I've got the points 3, 10. So the equation of line, y equals mx plus b. I'm doing a little flashback to algebra 1. So I'm going to say y2 minus y1 over x2 minus x1. And I get a slope of 10/3. And this one at least is easy because I know the y-intercept is 0. So I've got this line, y equals 10/3 x. And so now I'm going to go over here, and I wanted to know this at 2. So y equals 10/3 times 2 equals 20/3. Oh look, this is a little bit less than 7, so it's a good thing we didn't guess anyway. So 20 over 3. It says indicate units of measure though, so I must indicate units of measure in order to get credit. So 20 over 3, and it says meters per second. So meters per second. Okay, the velocity of runner B. So velocity of runner B at 2. This one should be a little bit more straightforward because we're given a function. So we've got 24. Instead of t, in this one I'm going to put in 2. And then in the denominator we're going to put 2t plus 3. I've already gone crazy. So 2 times 2 plus 3. 24 times 2 is 48. 4 plus 3 is 7. And I would leave it like that. I would leave it as 48 over 7 so that you don't mess it up if you try to simplify it anymore. And again, you need units. This is also in meters per second. Make sure that you answer the whole question. I've got the velocity of runner A, runner B at 2 seconds. I indicated the units of measure. I'm good. I don't even have to justify anymore. The next thing is find the acceleration. I'm only given velocity. Remember the connection between these. That I've got position, then velocity, then acceleration. Velocity is the derivative of position. Acceleration is the derivative of velocity. So when I'm looking for acceleration here, the acceleration at 2 is really the velocity at 2. It's just for runner A and runner B. So the acceleration for runner A at 2 is the same as the velocity for A at 2. Or I'm sorry, I said that wrong. Acceleration at 2 is the same as the derivative of velocity. Acceleration is the derivative of velocity. So I'm going to go up to the graph at 2, and I need the derivative. Derivative is the same thing as, yes, slope of the tangent. Okay, so if this is slope of the tangent, and this is just a line, The slope at that particular point, we already said, was 10/3. The slope of the tangent of a line is just the slope, the same thing that y equals mx plus b of long ago. Is just 10/3. Be careful, it says indicate units of measure, so you need units of measure. The acceleration at 2 is the derivative of velocity, so the change in velocity over time. Velocity was meters per second. Meters per second. But then I've got the change in velocity over the change in time, so this will become meters per second, or meters per second squared. Okay, the acceleration, again, so acceleration of runner B at time t equals 2 will be the same as the derivative for B at 2. But this one was given by a function. I've got 24t over 2t plus 3. Oh, this thing is going crazy. There we go. Okay, so I'm going to write this here so I don't have to keep flipping up. So that second one, the velocity, was given by that function, 24t over 2t plus 3. The quotient rule. V prime t would be the bottom times the derivative of the top. And I hope that you're looking at this and you're like, no, Miss Stewart, you're making a terrible mistake here. Don't forget parentheses, it makes a big difference. So the bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of 2t plus 3 is just 2 over the bottom squared. And now I want the derivative at 2. So I'm going to put 2 into all of those places. You can simplify first, but who wants to do that? Not me. And I already figured out this answer before. But take your time, put it in if you need to stop this, so that you can put in t is equal to 2. Do so now. When I did that, I got 72 over 49. And again, it's the derivative of velocity, so I'm finding the rate of change of velocity. So I would have meters per second. But because it's the derivative, and we're talking about acceleration, it's with respect to time. Meters per second, also known as meters per second